This is the first YouTube video for the ZiptieAI project. About 6 months ago, I decided to learn how to build and fly intelligent drones. Intelligent drone has artificial intelligence software running on it. I worked alone without assistance, and somehow I was able to build drones and fly them. And to keep track of my notes, which I made a lot of notes because I'm working by myself, I created the ZiptieAI wiki and Gdrive. And what you're seeing here is the homepage of the wiki. Then I decided to make this wiki public, and I recently created this YouTube video series as a high-level overview. I created it yesterday, and this is the first time I've created YouTube videos, so you have to bear with me. I'm still learning how to do this, and I don't have a good microphone. I don't have any fancy equipment, but I just wanted to get a basic YouTube video that explains a YouTube series that explains what ZiptieAI is. Now, if you look at the bottom of this page, this lists all of the websites available for ZiptieAI. And when you're on the wiki, this is the wiki, the Gdrive. If you go to the Gdrive, you're going to see a lot of documents. There are a lot of documents there, all numbered, that were basically, these documents started out as my lab notes when I was first doing these, learning how to do this. And they still kind of are lab notes, but I'm going to make them better later. And then this YouTube video playlist that's on here also. And then the ziptie'ai.com. I don't really use this much. It's just kind of a main website. It's not up to date. Right now I'm busy with getting the technical details in the wiki. And then there is a ZiptieAI docs page. So right now the wiki is the main thing. This wiki has been under construction for a long time. If you look over here on the right-hand side, you see all of the main epics. Here's like epic 1, and this is part 1, part 2, and there's a lot of content there. The numbering, you'll notice sometimes, is a little bit strange, and that's because I move things around. I number everything that I create to keep track of it, and I number manually, and inevitably when I move things around, the numbering gets off a little bit. But the main thing is it's all numbered, and you can find whatever you need. If you see a document, for example, that starts off with a number 13.1 in the Gdrive, 13.1, that means those are the documents for this section. So the whole wiki is done like this, so it's pretty easy to find documents and to keep track of things. But that took quite a long time to do. And the really detailed content is in the Gdrive Word files. For example, I'll give you an example here. This is a document for section 2.14. You see the number of the document. And we'll talk about that soon, but 2.14, if you go into the wiki, then that's going to be the document for this section right here. And if you look inside this document, this section here is about configuring the firmware on the SpeedyBee drone, and we'll talk about that later. But if you go into this document, what I did here was I found a YouTube video series that showed how to do this. It showed how to do this, but it was missing a lot of details. And I went through this video series. And this is the original author, what he did. And then I also show what I did, what I had to do. And if a lot of times there's details missing in the original YouTube, inevitably in these YouTube videos. But in my Word documents, since I'm doing Word documents and not videos, my Word documents eventually will have very detailed information and step by step. So I documented what I did. These doc files are my notes. But very often the experts, they would do everything first and get help from the manufacturers or developers, and only later make the video. And sometimes a lot is missing. So experts like to leave out things that are inconvenient to explain and require too much, they have too much detail. So one thing they like to leave out is the configuration of the radio controller and the receiver. And this receiver is on the drone, and this radio controller, connecting those two and configuring that is really complicated. I spent almost 3 days trying to get it. And almost all the expert videos I've seen, when they talk about configuring, when they talk about building your first drone, they always leave this part out. And that's, to me, is the most important part, the most difficult part. So I don't do that. I have everything step by step, everything that you need to do. So getting into the air ASAP, let's go back to this. This is the getting into the air ASAP page. And I'm trying to, let me show you what the end result of all this is going to be. You see, we have 3 epics here, epic 1, 2, and 3. And what you need to do in each of these epics is to choose one type of drone that you're going to build. And there's several options. There's options here for what kind of firmware you're going to use, but you're going to do one of these. And in the end, let's go to the end of this right here. In Epic 3, you are going to build, like I did, a drone that has a camera here in the red box. You can't see it; it's behind the wires for the battery. Then a Jetson Nano from NVIDIA. This is the artificial intelligence, the object recognition software runs on this. It's like a little Linux computer with a really powerful GPU. That's in the blue box. And then you have a small mobile phone battery that you use to power the Jetson Nano. This is my idea. I put this on the bottom of this copter because it only has 2 legs, and I was afraid if I put all that weight on the top, it might break some. And it worked out fairly well. In fact, it even maybe strengthens, makes the frame stronger. And so the goal was to build this and then fly it outdoors. And I did it about a week ago. Now, I started on this 6 months ago, and I just got it working a week ago because I kind of took a very roundabout way to do this. I started out doing a lot of other things before I finally figured out that this is what you really need to focus on to get into the air ASAP. For example, I spent almost 2 months, I think, in late 2023 setting up software in the loop simulation. That's total simulation. And This is because I found a fantastic website, a YouTube video series, which went through a lot of this. But that YouTube series was outdated and I had to make a lot of changes. Originally, you see this one right here. That's the old part number, chapter number. Originally, this was at the start of this website. But then later, I understood better. It's like, no, this is really not important. I put the word skip here because from a practical perspective, you're not going to want to do this for several reasons. And then I did a whole lot of things, but I wasn't in a hurry. I wasn't in a hurry to reach this goal. I didn't even understand that it should be the first goal until maybe a month or two ago. But anyway, this is the goal, and let me show you the video of my test of this AI drone. The first test about a week ago. So I'm out in a park, and the drone is hanging in the air. The camera is pointing away from me. The camera doesn't see me. So I'm not touching any of the controls. And let's see what happens. You see, I walk around from behind, and now I'm getting in front of the camera. The camera's looking at me. And the camera feed went to the Jetson Nano. There was a program on the Jetson Nano, a small Python program, and a very big program running running the GPU that recognized me as a person. And those algorithms on Jetson Nano are really, really good at recognizing things, object recognition. And when it recognized me, I just sent a simple command for the Pixhawk to land itself. And that's what happened. And that was the first test. The first test worked. So I've had a lot of trouble getting a lot of this stuff working. But the Pixhawk, I had really good luck with this Pixhawk. So anyway, we go back to the beginning of this. Getting into the Air ASAP. This right here. Let's go through this a little bit. So, as a newcomer, you want to get hands-on experience, I hope. So, and if you follow these directions, I'd say it'd take about 9 weeks to get through this whole thing. So, this is the workflow right here. It summarizes it. And why do I use the word epic? Because if you don't have experience and you're not careful, you can go down a rabbit hole or hit the wall, run into an area you can't solve. And so each one of these epics is a really big deal. You get an epic running, that's a really, really big deal, a major accomplishment for any newbie, which is what I was. So the first thing is get a work laptop. It's optional, but maybe recommended. Because you're going to need probably a Windows 11 and a Ubuntu machine, and you might need a laptop for working only on drones. The problem is sometimes you might need to install software that's not signed, and you're going to get a warning from your browser, and you might not feel comfortable installing that kind of stuff on a computer that you're doing your banking software on. That's just something you might want to think about. Then you need to buy the required work tools. Now, I made a shopping list. That lists everything that I've ordered from Amazon and from one other company, all the parts I've ordered. And I've ordered them pretty much by the epoch that I needed them for. And I bought them from Amazon. I downloaded all my orders automatically from Amazon, then modified the file simplified the table. And in here, you've got the Amazon identification number, standard identification number. So if you go to Amazon and you enter in this ID, you'll find the part right away. And here's the price. I spent a total of about $2,500, but you could probably do Epix 1.3 for maybe $1,500. I bought a lot of stuff that I did not need later. So this is really helpful, this shopping list I put together. And one thing I really focus on in this whole series is the idea of reference builds. And I recommend that whenever you're doing this, try to buy the exact hardware that I'm using. Because if you get any different hardware, you're going to have some differences between the setup, and very often you're going to end up running into trouble. So it's really helpful having a shopping list, and how I did this from start to finish, being very specific about all the parts that I used. Now, organize a work area. You're going to need space. You lose one little component, you might not be able to make progress. Usually they don't give you an extra screw or anything when you buy stuff. So here's a picture of my work table. I just kind of expanded my work table. I just built some wood work table and just kept getting bigger and bigger because I needed more space. So you really need to be organized. Be careful not to lose anything. Then we get here to Epic 1. Here is Epic 1. And you see Epic 1, the first part, FPV simulators. Now, I don't know why I have to laugh about this, but when I got started, I thought I didn't need to train in the simulator. I didn't think that was a big deal. It was a very big deal. Flying an FPV drone is like learning to ride a bike without training wheels. So I damaged my FPV. Here I was mowing grass, wet grass with my FPV. Because when these drones are scary. When you first start flying them, the motors are very powerful. And it's very difficult to control, and it's very difficult to understand how you have to move the sticks to control the flight. So here's the radio controller. And so it's got a couple sticks on here. You can't really see it, but here's one stick on the left and one on the right. Now here I am in the simulator. In the simulator, I connected this RC to the computer. And so when I was running the simulator, I was using my actual RC, and it's very important to get used to this. And this shows the movement of the sticks. If you move the stick on the left up, then you have more thrust. If you move it down, you go to zero thrust. If you move the stick left, right, if you move it left, the copter turns counterclockwise. Right is clockwise. The right stick, if you move it up, the nose goes down. If you move the stick down, the nose goes up. And if you move it left, right, if you move it left, the left side of the drone goes down. That's called the roll. And the right side, if you move the stick right, then the right side goes down. So you can move the sticks anywhere in this dark green area. And when you're flying, you have to have the instincts on how to move those sticks. It's very difficult to do. And I'd say give yourself 20 hours in the simulator. Just try to do half an hour a day. Do an hour a day. It'll make a huge difference, because what I was doing when I went out there, anytime I'd get scared about losing my drone, my drone's starting to get out of control, I always have this instinct of taking the left stick and moving it up. I don't know why I did that, but that got me into so much trouble. So definitely get a simulator. So after you've done the simulator, you want to build one of these 3 FPVs. SB-F405, that's the kind of processor. Now you're going to have the same hardware here, but the difference between these 3 is the firmware, the software that you install, like the core operating system of this drone. And there is iNav, Betaflight, and Autopilot. And I recommend iNav or Betaflight. I did Betaflight first, but I didn't really document it when I did it. Then I really documented it when I did iNav, but the Betaflight's also. I also did the Autopilot, and there are documents for the Autopilot right here. So even if you don't see something there's some kind of basic document on the Gdrive. So the first thing, where were we? I'm getting lost here. Okay. So we want to build our FPV drone. This is where we were. So buy the components and the required tools from the shopping list for Epic 1. And then we're going to build and fly the FPV copter as described in part 2. Now remember, I showed you this Word file previously, and this Word file, you see 2.1.4. Okay, so that is part of this Epic 2. So we're going to build and fly this iNav version of the FPV drone. And here are all the steps. And here's a minimal viable platform. Now when I first did my drone, I did it with this kind of homemade frame. It wasn't that difficult to make. And the reason I did that was, when you build your first drone in the normal, very small carbon fiber frame, all the wires are all scrunched together, and it can be really difficult to work when you're new with that kind of frame. And I had a problem with some connectors on the flight controller. I didn't know what the problem was, but I had some problem, and I started taking everything apart. And since I was doing it with this frame, with this plywood frame, it was very easy for me to take things apart and find the problem. So the test rig, and then we got, I talked to you before about installing this iNav configurator. And then in the end, what I did was, I had a flight indoors. I did a test flight of this drone on my kitchen table. You can see it's tied down. And that was really convenient to be testing all of this stuff inside and not having to go outside, making sure everything works. Then you do GPS and you add video. Later you put on a carbon frame. Here's the carbon frame, and I still added a piece of wood to make it easier. More space. And then you have missions. Missions are where the copter flies itself, and that doesn't really work well in iNav. And then I crashed my copter, as I said, because I just didn't have enough experience. And I'm going to go on vacation here soon. In early July, I'm going to go to Poland, Ukraine, Lithuania. And so before vacation, I didn't want to fix this. But I found the problem. And so now I need to, once I get back, I need to fix that. So that is the basic. That's basic Epic 1, building and flying the FPV drone. So then we want the small drone, fly the small FPV drone. Now we want to build a Pixhawk drone, a larger drone. And here the bigger drone is the Pixhawk drone. It's called Pixhawk because of this Pixhawk flight controller here in the middle. So it's a very much bigger device. You want to do this because the FPV drone is too small for the required AI components. The companion computer, it doesn't have the power to carry all that weight. And the FPV firmware doesn't have the required APIs, the software for an AI copter. You can't do things with the FPV that you can do with this Pixhawk. So, and like before, you need to buy the components and the required tools. And then you need to build and fly the copter. And if you come here, it's going to be pretty much the same as the same basic idea as when you did the FPV. And here's a picture of me flying it on my kitchen table when I first tested it. So there's one thing I want to talk to you about. When I did this, when I put together, this is a Holybro kit. It took Holybro, the company, the Chinese company that built this, said it took 15 minutes to put it together. It takes more like 4 hours minimum. I'd say about 4 hours. So the docx from Holybro was a single page with a few diagrams. And when I assembled it, I ended up reassembling it several times. And the experts end up doing the same thing. So the expert video that I was watching to do this, he said that Holybro said it would only take 15 minutes, or was it maybe 10 minutes? I think it was 10 minutes. And he kind of smiled and he said, well, he's not sure. These YouTube video experts, they'll never criticize manufacturers. A lot of times they won't tell you the real facts about these products. And so he sped up his video when he did his installation. And the sped up version was 10 minutes long. I mean, he sped it up really fast. So this one thing I want to tell you why ZiptieAI is in this one way much better than what you're going to find on the YouTube videos. These professional YouTubers, they're all working basically for the manufacturers of these products. They get free products, they get technical help from these guys. They're there to push selling stuff. And they're not going to ever tell you certain problems. They're just going to avoid them. So that also happened with this Holybro. This Holybro, not the Holybro, the small FPV. So if you remember, when I was first trying to get this to run, it wouldn't work. I almost went out and bought another flight controller because I thought there was something wrong with it. But I started taking things apart, and what I found was I got a magnifying glass and started looking at everything. There was a connector. There is a connector. There's two pieces here. There's something called an ESC, and there's something called a flight computer. I'm not sure I have a picture here. No, I don't have it. But there's a small cable that connects the two of them. And that cable has really small pins. And I discovered that the plastic female connector for that cable was defective. One of the holes for the pins was actually defective. The pin couldn't go through the hole because the hole wasn't there, or it was halfway there. And so what I did was I got out some very small tweezers, very tiny tweezers, and I kind of cut the hole out there where the pin should go. And then I noticed that the pin, very small pins, very fragile. It was the ground pin had been pushed into another pin. I thought maybe my flight controller has been ruined. But I took all that, fixed it, and then plugged it in, and magically everything worked. So this was a very, very major quality control problem. And the reason I mentioned that is that when I talked on a forum with some experts about this, they basically, kind of laughed at me. I said, when I found the solution, I said what the problem was. I said, when I was asking them what the problem might be, I said, SpeedyBee has a reputation as having a lot of quality problems. And they were like, no, they don't. SpeedyBee doesn't have problems. These are the developers for the actual for the firmware you're going to put on the SpeedyBee. And I can't help but think that these guys know that SpeedyBee has problems. And SpeedyBee, when you order stuff from Amazon, it's very rare that Amazon puts a notice beside a product that this is a product that's often returned. But they had such a warning by the SpeedyBee product when I bought it. And so I took a screenshot of that and posted it in the forum. And then these guys, they just remain silent. So they're not going to tell you, oh, there's a problem with SpeedyBee, or you got to be careful with this. No, they're going to say, oh, no, everything's fine. Everything's working fine. That's their business. So they're concerned. They're not concerned about you. You're not paying them. These manufacturers that they work for, basically, they are the ones that they're concerned about. But not ZiptieAI. So you build this large drone. Then, this video has already been a half hour. Sorry about that. I'm getting a little bit too long. But then you come in here, you come into Epic 3, buy the required components, follow the directions here. Okay, you configure the object recognition. This is a big deal. Configuring the object recognition algorithms, getting this all working on the Nano is not easy, but you see the date on this file. It's June 9th. I documented this step by step what I did, and it worked, no problem. So, I tell you, I often have problems with getting these drones working, but didn't have any problem with this. So we need to do the kitchen build and test, and this was kind of complicated. The kitchen build and test, that was kind of a complicated test. If you look in the Gdrive, let me open up this file quick. Maybe I already have it downloaded on my computer. No. So when you do the kitchen test, I document this in detail. Just give it a second to everything to come up here. Here's the object recognition. You see it works really, really good. I think there's a diagram here that I want to show you somewhere. Yeah, here it is. So this is the setup that I used to test to make sure everything was working. Now that'll be explained later in another video. But this gets a little bit complicated. But I set this up and it all worked. So you do the kitchen test, and then after that you go to the field and you build and test. You go to the field and you test it. And just what I want to say is the field test worked the first time. So I've had a lot of problems with these drones, with sometimes spending like 3 days to get my radio controller connected to the drone and all this stuff. But this worked the first time. So I was really happy. I've had very good experience with Pixhawk, and you'll notice that ArduPilot is to do Autopilot. I had lots of problems. I got everything installed on Autopilot, on the Pixhawk, and on the FPV. And for both of them, although the FPV and the Pixhawk are very different, I could never get the motors to turn. When I do a motor test, I could never get it to run. So finally, I switched to PX4. All the experts had said, Autopilot's much better. They've got community support. And PX4 is more for just the experts. I switched to PX4, and the PX4 was much, much easier. And here, for the FPV, iNav, Betaflight, they're much easier to use than Autopilot. So I kind of recommend staying away from Autopilot. And I think that's about all of this video. So just to recap what I explained here. The main thing about this video is when getting into the air ASAP. ZiptieAI focuses on getting you into the air, getting things done. I don't sell to manufacturers. I don't make any money off this website. This is like a personal project of mine. And that's the thing. And there's 3 epics to do that. And we went through step by step the epics using one kind of platform in each epic. So I hope you found this video interesting, and I'll see you in the next video.